Hi guys! We are the Group 8 and our presentation is all about the simple ways to measure evapotranspiration. So before we can measure evapotranspiration, it is important for us to know what is evapotranspiration. Evapotranspiration is merely a combination of the words evaporation and transpiration. So what do these two terms mean? Let us start with evaporation. Evaporation is the process by which liquid water is transformed into a gaseous state. Evaporation into a gas ceases when the gas reaches saturation. The molecules that escape the condensed stage have above average energies. Those left behind have below average energies. Evaporation is manifested by a decrease in the temperature of the condensed phase. Transpiration, on the other hand, is the process of water lost from plants through stomata. It accounts for 10% of the moisture in the atmosphere, and it depends on temperature, humidity, insolation, precipitation, soil type and saturation, wind, and land slope. So now, what is really evapotranspiration? Evapotranspiration is the loss of water from the soil both by evaporation from the soil surface and by transpiration from the leaves of the plants growing on it. For better understanding, here's a video illustration of evapotranspiration. When solar radiation from the sun heats up the water particle in the land surface, evaporation happens. The heat from the sun makes the water molecules move faster and faster until they move so fast and escape as a gas. On the other hand, transpiration is the water loss from plants. Plants take up water from the soil through its roots and later on it will evaporate from the aerial parts of the plants in a form of water vapor, which is a gas. Evapotranspiration is basically the combination of these two processes. Now that we have an idea about evapotranspiration, let us now proceed to the two methods of measuring evapotranspiration, which are the indirect method and the direct method. In the direct method, we have lysimetry method. And in the indirect method, we have catchment water balance and energy balance. The lysimetry method, from the direct way of measuring evapotranspiration, uses a measuring device called lysimeter, which can be used to measure the amount of actual ET which is released by plants, usually crops or trees, by recording the amount of precipitation that an area receives and the amount of loss through the soil. The amount of water lost by evapotranspiration can be calculated. Want to make and try this method? Follow these steps. Select a piece of ground. Fix the rain gauge for measuring the precipitation values in milliliters. Remove the turf and grasses from the small piece of land near the rain gauge and dug the soil. Tank is fixed there in such a way that 1 centimeter of it remains outside the ground surface, and then fill the tank with soil. Upper surface of tank is filled with turf or grasses that the soil cannot be seen. Then cover it with gravels or small stones and then with polythene sheets. The receiver is best placed with its top about 5 centimeters above ground so that surface water cannot enter. Pack soil around the apparatus, relate turf and apply water to bed in the turf and settle the soil when construction is complete. Measurements can begin in a few days. Experiment may continue for a few months or even for a year. In dry season, add water to the experimental area, but if the precipitation rate is sufficient, no need of water. The formula is evapotranspiration is equal to water added minus the percolated water. Here is the illustration of measuring through lysimeter. Let us now move to the indirect method of measuring evapotranspiration. For the first one, we have the catchment water balance. Evapotranspiration may be estimated by creating an equation of the water balance. The equation is evapotranspiration is equal to precipitation minus the change in storage, minus the stream flow, and minus the groundwater recharge. The second one is energy water balance. The actual evapotranspiration is estimated by the energy balance. For the equation, we have the energy needed to change the phase of water from liquid to gas is equal to the net radiation minus the soil heat flux and minus the sensible heat flux. Using instruments like a scintillometer, soil heat flux plates, or radiation meters, the components of the energy balance can be calculated. We can measure evapotranspiration in pots. The materials needed are weighing scale, marker, plants, tape, pen, and ruler. Our group will demonstrate how to do it.
Good evening everyone. Today is November 25, 2020 and the time is 6:52 p.m. Now, we have 5 different plants in order for us to observe and measure the evapotranspiration of each plant. Before starting the experiment, first, I need to put enough water to the soil and plants.
Good day everyone! Today is November 26, 2020 and the time is 1:02 p.m. Now is the first day to measure the evapotranspiration of the 5 different plants.
So now, we have to measure the height and the weight of each plant. So the first plant measures 22.5 centimeters. And the second plant measures 22 centimeters. The third plant measures 11 centimeters. And the fourth plant measures 7 centimeters. And finally, the height of the fifth plant is 6 centimeters. So now, we will measure the weight of each plant. The first plant measures 808 grams. The second plant weighs 796 grams. The third plant weighs 752 grams. The fourth plant weighs 788 grams. And finally, the fifth plant weighs 762 grams. So, see you tomorrow, guys.
Good day everyone! Now is November 27, 2020 and the time is 2:56 p.m. And now is the second day of measuring the evapotranspiration of 5 different plants. And Kevin will show you on how to measure it.
So for the second day of measuring the plants, the first plant measures for about 782 grams. The second plant measures 772 grams. The third plant weighs about 713 grams. The fourth plant weighs about 726 grams. And finally, the fifth plant measures for about 729 grams. So see you for editing.
And the data shows that there are differences in degree of evapotranspiration and variation among plants. In the first day, the data shows that plant 1 weigh about 808 grams, while in the second day, plant 1 weigh about 782 grams. We can determine the ET1 by subtracting the result of day 1 minus the result of day 2. So, the ET1 is 26. In the third day, plant 1 weigh about 765 grams. We can determine the ET2 by subtracting the result of day 2 minus the result of day 3. So, ET2 is 17. We can solve the average ET by adding ET1 plus ET2 divide 2. So, the average is 21.5. Finally, we can solve the final evapotranspiration of plants within the span of 3 days by dividing the area of pot, which is 98.5 cm squared, from the average ET. So the final ET of plant is 0.22. We can do the same process to other plants, and the final ET of plant 2, 3, 4, and 5 is 0.20, 0.27, 0.57, and 0.26 respectively. In data 2, looking at the individual plants and their ET on a centimeters per day basis, they differ. It is because there are probably both real biological reasons for differences in ET among plants, and there are also probably some artifacts in expressing ET on an area where you've got a plant extending out over the edge of the container. In conclusion, evapotranspiration is an important process in the water cycle because it is responsible for 15% of the atmosphere's water vapor. Without that input of water vapor, clouds couldn't form and precipitation will never fall. Evapotranspiration is the combined name for the processes of evaporation and transpiration. When water vapor is released into the atmosphere, both processes are involved, so they have been combined into one word to cover all bases.